So 3b part 3 says hence or otherwise solve this equation. So I'm firstly going to do it using the hence method. So that means that look previously in the question and see if there's something that will help you finish this faster. But just in case this would ever come up on its own without any previous help, I'm also going to solve it using another method as well. So let's look at hence, how would I solve this question? Well, firstly, I need to look and see that these aren't in the same base. So I'm just going to change this one, doesn't matter really which one I change, into the same base as this one here. So let's change into base 3. Now if you want to change base, you have to go to your log tables and look at your change of base formula, and you carefully do that where you have the log of, I'm just changing this base here, log of 3 in the new base, remember you always want to be in the new base, over log of the old base in the new base. So that's me changing base there. This can stay the same, is equal to 10 over 3. This log 3 in the base 3 is just 1. Sorry, plus log x in the base 3 is equal to 10 over 3. And now I'm going to look back to the question and see is there anything that I've done previously that was helpful. And if I go back to B part 1, I can see here that I have something plus 1 over that same thing is equal to 10 over 3. And I realise that something was either of these two solutions. And here I have the same thing, something plus 1 over something is equal to 10 over 3. That means that this is the same as what I originally found out x to be in part 1. So log x in the base 3 could possibly be a third, or log x in the base 3 could be 3. And again, just taking it out of log format, that's 3 to the power of a third is equal to x. So I have the cubed root of 3 is x, or 3 to the power of 3 is equal to x. So x is equal to 27. And depending on how they asked me to write this, I might round it off if they said so, but they didn't, so I can leave it just like that. Or like this would be also fine. Now, if this question came up without any help, like it did there, well, I could use another method. So hence, I use this method. Otherwise, I'm just going to pretend I never had any help in the question, and I'm going to solve this from the start. So this is just another way to do this. And I'm again going to go with the fact that this needs to change base, or this one needs to change base, it doesn't matter. So when I change base, that's log x in the base 3, and this one is log 3 in the base 3 all over log x in the base 3 is equal to 10 over 3. That gives me log x in the base 3 plus 1 all over log x in the base 3 is equal to 10 over 3. Now I could use substitution here instead. So I'm going to let y equal to log x in the base 3. So I end up with y plus 1 all over y is equal to 10 over 3. I'm going to multiply across by y, and if y squared plus 1 is equal to 10y over 3. And I could then multiply across by 3, so that's 3y squared plus 3 is equal to 10y, so that's 3y squared minus 10y plus 3 equals 0. You can solve that, and that's a 9y, a 1y, minus. You could do this faster. Right, that is meant to be a 3. from here, I have to remember that I introduced y, so I better go back and go that log of x in the base 3 is equal to a third, or log of x in the base 3 is equal to 3, and then taking it out of log format, again x is equal to 3 to the power of a third, or x is equal to 3 to the power of 3, which is 27.